Imagine a universe that's not speeding up endlessly into oblivion, but quietly slowing down, potentially even reversing course toward a dramatic collapse. That's the startling possibility raised by a fresh astronomical study, and it's flipping our understanding of cosmic destiny on its head. But here's where it gets controversial. This research directly challenges the Nobel Prize-winning idea that the universe's expansion is accelerating, suggesting instead that it's decelerating. If these findings hold up, they could rewrite the script for how everything ends, swapping eternal expansion for a scenario where the cosmos collapses back on itself in what's called the Big Crunch. On top of that, the mysterious force believed to drive this expansion, known as dark energy, might actually be losing strength over time, weakening its grip on the galaxies. Let's break this down a bit for those new to these cosmic concepts. Dark energy is like an invisible push that's been fought to make the universe grow faster, countering the pull of gravity. If it's fading, gravity could regain control, leading to a slowdown. And the Big Crunch? Picture it as the reverse of the Big Bang, everything pulling back together in a fiery reunion. It's a wild idea that could mean our universe has a finite lifespan, not an infinite one. The team, led by Professor Young-Wook Lee from Yonsei University in South Korea, analyzed data that points to a universe already in a decelerating expansion phase. Our work indicates the cosmos has shifted into this slowdown right now, and dark energy is changing much quicker than we ever imagined, Lee explained. Confirming this would revolutionize cosmology, overturning the dark energy discovery from 27 years ago like fixing a shirt buttoned wrong from the start. Of course, this isn't going to be accepted overnight. Expect some serious doubt from the scientific community. After all, challenging a Nobel-winning theory is no small feat. But it's worth noting that the influential DESI collaboration came to a strikingly similar conclusion just earlier this year, sparking a heated debate among experts about what dark energy really is and where the universe is headed. And this is the part most people miss. The study dives into the reliability of those pivotal supernova observations that kicked off the dark energy era. Back in the 1990s, we assumed gravity was acting like a cosmic brake, pulling galaxies together and slowing expansion. But then, astronomers measured the universe's growth using exploding stars called Type Ia supernova. These stars were seen as standard candles, reliable beacons of light that stay fairly consistent in brightness, allowing scientists to gauge distances across space. By checking how much their light is stretched or redshifted, a shift toward red wavelengths caused by the universe expanding, like a siren sounding lower as it moves away, researchers could track how fast different regions were receding. What they found was surprising. Distant supernova appeared dimmer than they'd be in a slowing universe, leading to the conclusion that expansion was speeding up. Yet, the new research proposes a different twist. By recalculating the ages of 300 galaxies hosting these supernova using an alternative approach, the team uncovered that early universe stars varied in their properties, producing generally fainter explosions on average. Correcting for this built-in bias doesn't stop expansion, but it indicates it's tapering off, with dark energy diminishing. If it keeps dropping and turns negative, theoretically, we're headed for that Big Crunch. It's a bold reinterpretation that could explain the dimness without needing acceleration. Professor Carlos Frank, a cosmologist at Durham University, not connected to the study, called the results definitely interesting and provocative, though he cautioned they might still be off base. You can't just brush this aside. They've released compelling evidence with huge ramifications, he noted. The research appears in the monthly notices of the Royal Astronomical Society. So what do you think? Does this shake your faith in the accelerating universe theory? Or do you side with the skeptics? Could dark energy really be waning? Or is there another force at play we've yet to discover? Drop your thoughts in the comments. Let's debate the fate of the cosmos.